Um, Today we're going to talk about something called a regular expression. You can live without them. Your life becomes easier with them. You can live without regular expressions for the most part, but certain tasks can become easier. So has anyone heard about regular expressions? What do you know? What have you heard? What do you know? Etc.
If I'm thinking right, is this what Regex is? Right. And it's a way of targeting characters, at least in the ways I've seen it implemented. I'm sure there are other ways to use it, but it's like a shorthand for like if you need to find all like if you want to discount all uppercase letters, you could use like a regex expression to do it very succinctly by just like A to Z kind of thing, versus having to write explicitly out like A comma, like capital A, capital B, capital C, I think something like that.
That's right. That's right. It's essentially like a pattern that you can search for or match in string, right? Okay. And yeah, you mentioned a regular expression, sometimes called regex, regexp. Those are all the same. Regular expressions. They're talking about regular expressions, and regular expressions are not unique to JavaScript. They are in I think probably all programming languages. So let's take some notes here. Actually, let me just get rid of this. So
it's funny. Like I remember starting on when we were starting off, and I was like researching like how to do these like back when we were like learning the very basics of JavaScript, and I would get a lot of answers with regex like oh here's how you do it, like offhandedly here's how you do it real quick in like one line. And I was like, and I'm like, yeah, it works, but this is not showing me what I needed to know.
Yeah, I think it was actually so. We decided to regex was shown to me in Unit 1, but it was like at that point like it was just complicated and I didn't see a lot of opportunity to use it. So this year we decided to leave it for the end as like an extra lesson, because again you can live without them, but some things become easier with them. So yeah, sometimes this is a regular expression. Expression. How do you spell expression? Is that correct? Something called regex, or spell also reg, like exp. This name actually, I don't know where it comes from. I was trying to find out, but the regular, I haven't been able to like really find why is it called regular expression. But ultimately, if you remember one thing, it's a pattern, or describes a pattern. Describes a string pattern. So if you have to remember one thing, remember this. That it describes a string pattern. And let's jump in. Let's see the first one. Okay. So, well, why are they? They're helpful for searching elements in the string, extracting parts of the string, replacing parts of the string. So, yeah, and these are some of the keywords that we're going to look at: characters, match, search, flags, replace, groups, and yeah. Also, feel free to jump at any point with any question or any thought. Yeah, again, simply put, it's just a pattern that describes a string, and we use this pattern to search, replace, or manipulate strings. And a lot of you already know that a lot of the things we deal with strings like very often on a day-to-day basis. So expanding on that a little bit, regular expression is a pattern that's matched against a target string, and the pattern just provides a way to describe a complex sequence of characters. in the simplest form, a regex can be just a few characters that need to match exactly. So we have, for instance, this pattern. Regexes we write in forward slashes, and we're gonna get into that a little bit more.
Sorry, Alejo,
yeah.
to interrupt. Maybe you're not sharing the right screen.
Wait, what screen am I sharing? What do you see?
VS Code exercises.
Dang it. Thank you. This actually happens quite often. Wait, zoom. Now what's trying to You see in the browser now? No.
Yes.
Okay, great. Thank you. Okay. Let me close this. Okay. So again, the regular expression is just a pattern, and it provides a way for us to describe a complex, simple or complex sequence of characters, and we can match against those. And this is an example, for instance. We have XYZ inside of forward slashes. The forward slashes is what makes it a regular expression. And XYZ. So this we can use this pattern to match exactly an X followed by a Y followed by a Z. So if we have this string, you do ABC and then XYZ, and we match it against the pattern XYZ, we'll find out the match happens on the last word on XYZ at the end of the string. Now, this is another example where we have a regular expression describing a pattern on a string. So let's say we have the string, I earned 12 gold medals throughout my career. The pattern inside of forward slashes again. But now this time with something we'll get into it later on. /D, /D. This /D means it matches any digit. So any number within the string. And in this case, this pattern, /D will match the number 12 in this string. Because maybe we want to find the numbers in a string for whatever reason to add them up or so on. And this is a pattern that will let us do that. And it matches any digit from 0 to 9. Mm-hmm. Okay, and this last part, regular expressions are usually used by string searching algorithms for find and replace operations on a string, or for input validation. So with regular expressions, you could say, in fact, this is the way that is done for most, whenever you go to a form online and you try and it asks you for an email and you put inside something that's not an email, it's a regular expression, the one that's running under the hood, telling you whether that's an email or not. Or for a phone number that you want to validate, and stuff like that. So this is one of the biggest areas of use for regular expressions, input validations. I would say, like, yeah, the first one is just like it says here, like whenever you want to find something on a string that you're interested in, or input validation. Any questions so far here, or thoughts?
What, I'm sorry, so what exactly is a regex returning? Are we getting, will we get back the 12 that we're looking for, or will we get back a truthy or a falsy, or?
We'll get into that in a few minutes, but
oh, okay.
Yeah, we'll get whatever, we'll get the match, and we'll get the position with the match happening.
Cool, thank you.
So here we just saw like a few simple patterns and what they will match. Let's get into how to create one and using one in JavaScript. So there's two ways to create a regex. One is doing it literally with forward slashes and just putting the pattern in the middle. or using the regular expression constructor function. So let's take a look at this example that we saw earlier, but now in JavaScript. So we have a string. Oh, actually, I made a mistake here. See, this is supposed to be Z. But ignore that. This is, or just know that this C is supposed to be a Z, the last letter of the alphabet. I get confused sometimes still. I should fix that. But basically, wait, I fixed it here? Yeah, I fixed it here, but I forgot to do it. So if we have this string ABC and then XYZ, and we have this pattern that we create, note how we're creating it with the regex constructor function, then we can do something like this, pattern.exec text. And exec is a function that patterns have that will let us execute the pattern on the text string. And what we will get is something like this, XYZ, or we get an array. We get an array back. That's important. We get an array back with some extra properties. So it's kind of like a funny array. It's an array, first of all, but it has a few extra properties. It has like index and an input. Let's actually take a look at this in REPL. Languages. Oh, it says error here. That's bigger. It's bigger. Okay. Let's replace these for a z, xyz. We have a pattern that's executed, and let's see what we get. So I'm gonna run, and here's what we get. We get an array. The first element of the array, this is actually an array with only one, with length 1. Let's see, console log. Let's console log this. Let's console log. Should let's do this. Let match equal this. Match, and there's a match. Right. Let's run this. So note here that then pattern.exec returns to you an array. In this case, we save that array into a match. And it has only one element inside, which is the match. But the array has some extra properties that might be helpful, like index, input, and groups. Groups is undefined for now. But index is indicating where the match happened. And the input is just the same as whatever the string that we executed the pattern on. But note that it looks kind of weird because we are not used to seeing an array that gets printed like this. It's just that this is an array, it's just that the regular expression returns an array with some extra stuff like an index. So for instance, if I do match.index, I should be able to get 20. And so on. Questions or thoughts on this one?
What will happen if you have 2 of XYZ?
Oh, that's a great question. Let's take a look at this. And XYZ. Good question. Let's run. Okay. What do we see?
Catch only the first one.
It caught only the first one. We'll see how we can find them all in a few minutes. So that's something that actually, that's a good point. Regular expressions will stop on the first match and they won't keep looking unless we do something different to tell it to look at everything, find them all. Other questions or thoughts?
While this is built like an array with a single element inside, can it be searched like an object since it's got kind of an object key value pair system going on inside of it?
Mm-hmm. That is a good question. I would say so. Let's try to do this. This is a bit off, going a little bit of a tangent, but I think I like the question. So a way in which we could verify that is if we loop over the array with let key of, is it key of or in? Key in match console.log match. Okay, let's do this. Key holds match key. Let's see this. Yep. So we had the input. So it's like it's a weird mix. But if we remember at first that I think I might have said this like in Unit 1 or Unit 2, everything in JavaScript is an object. So even if array is an object, and you know that you could do that length. That length is like keyed into the length property of the array, right? It's just that the length property of the array, when you print out the array, is hidden, but it's still there, and you can still access it. And in this case, these are not hidden; they are printed here. Mm-hmm. So yeah, we can loop over as if it was an object. If we do, what if we do like match that for each? For each element console log. I wonder if this one will only loop over the indices. Where is the?
It's the XYZ.
Mm-hmm. So as we see this, we see that for each will only loop on the elements inside, not in the properties. In this case, if we look back at the match, we see that the match is an array with only one element. These are properties. This is one element of the array. And again, if we see the length is 1. The length of this array is 1. It only has one thing inside. Mm-hmm. Other questions or thoughts?
I have a question about the properties. So
Mm-hmm.
all of that are properties of exec, right?
They get created because of exec. They're not part of they're not properties of exec. They are created because the array that is returned by exec is a special array in the fact that it has properties inside.
And my other question was going to be about groups. Why is it undefined?
Yeah, we'll get into that like in a few minutes. Groups is when we want to capture stuff from the string, from the matches, and we want to group them. And we'll get into that in a few minutes. Appreciate the questions. Okay, so I said we can create a regex like this. We could also create a regex with a literal expression, just like this. Actually, let me put it here. These two are exactly the same. We runs exactly in the same way. When you're using the regular expression constructor, you need to pass in a string that represents the pattern. When you do it literally, you skip the quotes and instead you use /. like this. And again, these two are exactly the same way. So these are the two ways in which you can create a pattern. We could also have done this, just like here, X, Y, Z. And oops, pattern is not defined. Oh, sorry, I put it in the wrong place. Here, which is can be a bit weird, but still works. So this is a regular expression. And in fact, before we move on, let's put here back the pattern. Look what happens if I console log the pattern here. Pattern. I haven't seen this. Okay. That's not very exciting. We just get the exact same thing. Let's say we get something else with this one. We don't get anything. I want to see if there's JSON.stringify. See what this says. Stringify. Oh, okay. I had never seen. I forgot to console log it for some reason, but I wanted to see if the pattern has something. I think the pattern has some properties that I was reading, like last index. Yeah, the pattern has some properties. The last index is one of them, and I wanted to see if we could actually sort of like see the object representation. And I didn't research how to do that. But for the most part, we don't really need to inspect the pattern. Okay. So we know there's two ways to create a regex. Let's take a look at what comes next. Oh, this is important. When there is no match, the return will be null. So I keep. Since I have you all on top, that hides my tabs, so it's not easy to click, but I found a way. Anyway, so if there's no match, for instance, let's say we're looking for XYC as I had initially put wrong. We're gonna get right now it breaks. We see the console log this on console log match. It returned null, and then after that it broke because null doesn't have a length property. So we'll need to check if there's a match and we're interested in the length, then let's look at that. If there's no match, skip it. So this could be simply used to like see if any string has a substring inside. But okay, just remember that when there is no match, it returns null. It doesn't return an array. It doesn't return an empty array. It doesn't return an object. It returns null. Cool. Okay. So where can you use regular expressions in JavaScript? There's these functions, 7 functions in total that you could use. You could use on the exec, you could use on test. And note that these are being executed on the regular expression object. So this is, you put the pattern first, that exec, and then you pass in the string, or the pattern and that test. That test it just returns true or false if the pattern was found. It doesn't return to you the location, or it doesn't return to you what it was found. It returns true or false if it was found. So if we go here, REPL, and I do, what was it, test? I think. I get false. Let me comment out this. I get false because that pattern was not found. Put back the Z, I get true. So just like a handy function there. Now these are two in the regular expression like object using the pattern first, then exec or test. The rest of them are on the string object. So you can do string that match all, search, replace all, and split. From these, exec and match are almost exactly the same. There's one small difference that we'll explore. But let's take a look at that. Yeah, we have this example here, but let's do it with the example that we have. I'm gonna get rid of these for loops. Okay, so let's do maybe text 1, text 2. I just want us to see that it's actually exactly the same for the most part. We'll see the difference in a few minutes. So we can do text 2. We put the string first, and then we can do match, and then we put the pattern here. And then let's just console log match 1, match 2. We'll see that the result should be the same. Let's run this. That seems like it's taking some time, but I think that's REPL. Let me just refresh. Copy this in case. Let's see. I don't know why it says that's some error. Let's see if we can just get rid of that. Oh. They say they're running an internal error. Let's put this next one. Okay, and remember this is the exec here. So what we want to see is that pattern.exec, which is one way, or text.match, and then the pattern should give us the same result. And we see here the results. So these are two ways in which we can execute the regular expression on a string. We can put a string and then say string.match, and then the pattern, or the pattern first exec on this string. Okay. On why would you pick one over the other? I think it comes down to personal preference, and we'll see the difference why I will prefer to use match sometimes and why I prefer to use exec sometimes. Okay. So just remember that then here, these are all the functions where you can use a regular expression. You can use a regular expression to split a string on a particular pattern, to search, to replace, and so on. This table is in this document here on MDN that can link you to all the functions for you to look at how they operate. Okay, so we saw an example there. Now let's take a look at let's take a look at what they're called character classes. So this is sort of just some other pattern. So we saw that /d matches a digit. And actually, let's see that one again. We saw it here, but we never run it. I might be wrong. Let's put let's comment this out. Let's do let str with nums. And let's do console log str. Let's do the pattern. /d, /d, and we do pattern that match str with nums. Hello?
Is it the other way around? str nums that much?
That's right. That's right. You can see that I still get confused. I meant to put exec, or the other way around. It will be the same. So here we see that we find the 12. That is what match on this string, and we find that that is at index 9. What do you think will happen if I remove one backslash?
It will be 1 and x9 as well.
Let's take a look. Got it. We only match the 1. We didn't match the 2. Cool. So that's one. These are called character classes. They just sort of, you can use them as sort of wildcards for more characters. D will match any character from 0 to 9. There is backslash capital D matches anything that is not a digit. So it's sort of the opposite. Space matches space symbols, and that means tabs, new lines, space. These are tab. R, I think, is return, new line, and F. I don't remember what F is. I think F is something that we don't see much, line feed. Wait, let's actually do a quick Google search. Character /F. The form feed. So this I find quite interesting, where a lot of computers, like, or those characters are still like from whenever we had terminals that were basically like a typewriter, where a typewriter, I don't know, like, give me a thumbs up if you ever type anything on a typewriter. Okay, I see 2. Oh, I feel fortunate. I got to, at my house when I was a kid, they used to have 1. And it was, you will type, and then you will hit enter, and then you have to move the paper so that you go to the next line, and you have to put the carriage back to the beginning to start typing at the end of the line. This is incredible that after many years since those, there's still some parts that are kind of like that, and that's what it means. Like, for instance, the return character. Where are we? This is a bit off topic, but I think it's still sort of interesting. R is for the carriage, I think, return. Not console log. Character. And Yeah, let's see if I can just show you a small example. Let's go back here. So let's do console log hello R. Let me put you back up here. This. Okay. That gave us hello. Let's put backslash. Actually, this is kind of hard to see. The tab, there should be a tab here. You can see it when I hover over it. There's a tab there. There is, let's do F. Whoa. There's, we can't really see as much, but I was expecting with hello world to, because this means return, to have a raise hello and have written world, as if you had returned the carriage without going on to the next line. I think I had played with this before, but I just don't remember. But just know that those are sort of special characters, that, you know, written with the backslash R or backslash something else.
In the Stack Overflow document you last opened, they have like something for Windows and something for Linux, so it's not the same.
Mm-hmm. In Unix, Mac are so a new line. What a new line really means, like if we think of the typewriters, it means come back to the beginning and then move the page so that we go onto the new line. Let's see JavaScript. Let's see JavaScript. Okay, grammar and types. Let's see what do we have here. Form feed character, but it's like it's a bit hard to see where is this F gonna be used? Form feed.
Try to hit the try it yourself.
And this will do it in our HTML search result 16. Wait, let's see this. Oh, but this, oh, okay, this is search. They just found the position of this character with this pattern. Log str. Yeah, we can't really see what the F is doing there, but yeah, just know that those are special characters. And those are considered for those, the ones that you're more interested in will be the new line, the new line and the tab. You can match those with \s. So \s will match. It will match a space. This is actually a space. A tab or a new line. Let's actually see some of those here with the Regex. So here, if we have backslash D, we saw that matched the numbers, push S, and let's run. So we see that with backslash S, we're matching this space that's here. And we see the space here, and we see that that space is at index 1. If we had like a tab here instead of a space, we run, it will match the tab. If we have a new line, let's also console log str with nums. So let's say we have a tab, and that will be like the string will be that number, then the tab character, which is just this wider space, and the rest of the string. We see that we're matching the tab character, which when it's printed, it's just this space. But when we want to sort of spell it out, we will need to do \t. And we see that that's at index 1. If we do \n, which is a new line, see that I then now is separated by a new line from the rest of the string, and we're here matching our S. This pattern here is matching that new line as well. So if you want to match something that starts with a space, ends with a space, or with a new line, you may want to use the \s. Then we have not anything that's not a space. We see word characters, that's the W4, and note that also the names are easy to remember. \d is for word characters. That means Latin letters, digits, and underscore. So let's take a look at that on here. We look for a W. What do you think we're gonna see is matching?
0 and I.
0 and I. Let's take a look. That's right. We got the first letter and I. So another important thing there to notice is that \w matches uppercase and lowercase. It matches uppercase and lowercase. So it doesn't matter if that's I capital or I lowercase. It must. Right now, this is only matching the first one that matches the pattern. In this case, anything that's a word character, we'll stop there. Okay, and one important one, the dot are sort of like a wild card. The dot matches anything except a new line. Unless we use a flag as to match the new line, but without that, only the new line. Everything without the new line. So what do you think we're gonna get if I do REPL? What do you think if I do this? All right, and let's do this. What are we gonna match here if I do n dot?
All M's in the...
And what else?
I believe like medals through my careers.
Say that again.
I believe like medals through my career. So the index of M, and it will match all the rest after this, after the M.
I see. Will we have other options? Thank you, Douglas, from the main. Other things that it will match. So we saw that M will match an M, right? That's a literal M that we're searching for. And we said the period is for any other character. So anyone wants to take a stab at that? A bit more, like more specific than what Amin and Douglas said.
I may be correct myself. So it will match the M and E, and it will give you the index of M.
That's right. That's right. Let's take a look at that. So it matches, is searching for an M, and it sees that, if we put a space here, it sees that the first M that it found is this one on metals. And then it doesn't matter what the next character is, it will match that. In fact, if I put like MX, it'll match MX, because the dot matches any character. So here's another question. What if I do this?
I space E.
I space E. Oh, maybe. Do we have other options? See? I space E. That's correct. It matches the I, any character, followed by a space, followed by any other character. That's the first two to match. Mm-hmm. Okay. So here's an exercise. Actually, we'll get to exercises a bit later, because this one I don't have right on top of my head. But any questions or thoughts here so far? No. Okay. Let's keep going. So this is another example here. We have an H followed by any character, followed by any character, followed by an E. If we have this text does not have XYZ spelled out. That will match have. It will match anything that is in between an H and an E. Mm-hmm. Match that. The dot stands for any single character. And this is also important, exactly one of them. So let's take a look at this. This is an interesting examples here. So here, let's say we're asked to find all the negations that are there, or if a string has a negation. So here we have like the text does not have XYZ. And here, instead of spelling out does not, we use I forgot what these are called, doesn't. Does anyone remember what these are called?
It's a contraction?
Contraction, exactly, thank you. And we're ignore the fact that we're getting rid of the apostrophe there, so that we're just spelling out like that. So let's say we have a pattern to match these two, to match the not and to match the NT for the contraption. So what we can do is, here we're doing it with tests, so true and true. If we try to test one not on doesn't, that doesn't work because there is nowhere to be found not. And if we try the NT on does not, that is not found because there is no NT here. But here we're gonna see an extra character that we have, which is the question mark. So this question mark would allow us to match both cases, doesn't and does not. So basically, and we'll get into more details in a few. Wait, sorry. I think I was feeling like I was gonna sneeze, but it went away. The question mark here, if we pass it with doesn't have and does not have, both will match. because the question mark means one or none matches of the preceding character. So this is saying, you can think of it as like this O and question mark. O and question mark means match N followed by an O, or maybe not followed by an O, but definitely after followed by a T. Actually, this is an example that we can run on this tool that I think Douglas shared with us at some point. Regex regexr.com is a tool where we can try regular expressions. And let's see, we have this. These are pattern not.
You did the T optional, Alejo.
Oh, thank you. So here, not. So we can see this even highlights where the matches are, which is kind of nice. So this is a super helpful tool, regexr.com. Thank you, Douglas, for sharing it. It can help you sort of debug your regular expression and see where it's matching. But basically here we're saying O. Here, let's see. So this is also like a cool part here, that it breaks it down. It explains the regular expression for you. So we see N matches the N character, case sensitive at this point. O matches the O character, but we have a question mark, which is a quantifier. We're gonna get into a few more in a bit. And that matches between 0 and 1 of the preceding token, or that preceding character. So these two in combinations means they match it if there is an O. If there's no O, don't worry. It's like the O is sort of optional, as Amin said it earlier. And the T matches the T character, specifically in this case sensitive. So that gives us a match here and a match here. Let's do.
Can you do like two options, kind of N, O, question mark, apostrophe, question mark, and T?
I think I see where you're going. You want to match if we have the apostrophe here? Okay. Oh, but so just to answer your question, yes, we can have as many optionals as we want. Look at that. So does anybody want to try a stab at this? Why is it matching where it's matching?
It will match the first T in the, and no, it's case sensitive, so it's the text.
But why is it matching here? I could say, like in plain English, why is it matching here?
Because it says it's first looking for N by its optional, then O by its optional, then T. And the first T that match is the one from text.
That's right. And the same for this one here. And here, the match is N, but it's optional. I think I actually like that way that you're describing it. I mean, N is optional, but now N is there. So let's match that. O is optional. O is not here. But is it followed by a T? Yes, it is. Let's match it. And here is like all of them. N is optional. O is optional, but they're present. And T is the one that must be there. And we have it there. Cool. Questions or thoughts on this one? Okay. So, right. What if we want to match? Yeah, this is an interesting one. What if we want to match an exact dot? What we'll need to do is escape that dot by a /. So if we have here, let's go back to regex r. Oh no. Tabs. Let me close some of these tabs that I don't need anymore. So this is just, what if we want to match the dot? Actually, look at this. When I put dot, that is matching all of them. And you see this G here? This G means global search. We're gonna see it in a bit. And that means find them all, basically. And that's why all of them are highlighted. But what if we want to match only the dot? What we shouldn't do is escape it. Escape the dot with a forward slash. So with a backward slash. What that means is if you're using a character that has a special meaning in a regular expression, like the dot or the question mark, let's see, like let's say we have a question mark here. And even this one is another one that has a special meaning. Let's say I should try this. Okay, this one does match. A square bracket. Square bracket has a special meaning on a regular expression, the same as the question mark. If we want to match those, we need to escape them. What that means is you do backward slash, and then whatever you want to match, that matches that one. Backward slash, square bracket to match the literal one. So just remember that if you want to match a character that might have a special meaning on a regex, like the literal period or the opening square bracket, you will need to escape them with this. And you can even see escape character matches the opening square brackets character. Cool. Let's go back here. Okay, so let's see sets and ranges. This is an example of a set. Oh, that's why I'm missing. No, okay. This is, we can have a set of characters to match inside of square brackets, like this. And what this is doing is, this is a pattern with a set of characters. What this will do is match anything that is either an A or an E or an I or an O or an U, a U. And find whatever matches first and return that. So if we run this, we will see that we get E, the E in Z here, and that is our index 2. So this will match any vowel, basically. And here, let's do, actually, let's move on from there. But this is another one. If you want to find either an A, an O, or a U, that's that. Note here how this is like in square brackets, the set is basically saying one of this. Instead of one of these followed by one of these followed by one of these, is just one of them. So let's see. Let's go back here. Let's see what this gives us if we run on this. So we see that when I run that, that matches all of the vowels basically. So if you had to, for some reason, yeah, if you had to count how many vowels that will give you, and so on. And you can see here, character set, delimited with the square brackets, matches any characters in the set. Oh, this is cool. It even gives us like some hints and stuff here. So it matches any character in the set. Let's see, and we can combine them. What this means is we can find here, if we find any vowel that is followed by an S, we'll match ES in these two places. This is match any vowel followed by an S. Or match any vowel followed by a question mark. And so on. So this is a character set. What's another example of this? Let's say we wanted to do, actually, I think that one is here. So yeah, let's just see this, and at the end we can do some exercises. So in the case, so this is a set. In the case, we also have ranges. So this is an example here. We can use this range, and in the range, just like I said, goes inside of square brackets. This will match any number from 0 to 9. But let's actually look at this example. So let's say we wanted to match all the letters of the alphabet. So we could do this. This is matching all the letters of the alphabet. This is a set with all of them. And we see that the only things that don't match here is the spaces with that dot, and the square brackets, and the question mark. So we could do that, spell it out, or we can also use a range. For instance, we do A through Z. We match all of them that are A through Z, and here is case sensitive. We haven't seen case insensitive yet. For case insensitive, oops, we can just do the I. If we add I at the end here, which seems to be just with this, in this flag option, but again, this will work in JavaScript as well. That will match A through Z, doesn't matter if it's uppercase or lowercase. And again, that will match only those characters. If we didn't use I, we could also match, this will match only the lowercase ones. You could say, we can make another range for the uppercase ones. So these are ranges. They are character set, and this is a range. We can see the explanation here. A through Z. So those are useful ranges 0 to 9, or let's say 5 to 9. 5 to 9 will match anything that's between a 5 and a 9. So if we have like 6 apples, that matches there. 999, that is matching there. Wait, what if we remove the global one? Oh yeah, if we remove the global one, we see that it only matches the first one. Okay, so matching a number, what if we have a 4? 4 is not matched because it's not in the range 5 to 9. We do 3, now that one is the one that matches. So those are sets and ranges. Questions or thoughts?
This is maybe jumping 8 steps ahead, but can you use string interpolation within like inside of a one of these regex expressions, regular expressions? Like, could I, like, say you're trying to, for example, we were trying to find a range between 1 and 5, and you're trying to, like, it's a moving number based on different qualifiers. Like you're like, for lack of a better example, like it's like a video game, right? And you can and you're rolling a die to determine whether or not you can make a successful hit, but you can only do it if it's like between 1 and 4, but sometimes between 1 and 2. Can you could you use JavaScript to change the like that internally, based on other conditions, or is a regex set in stone and you can't really manipulate it.
So for the example you're describing, what we can do is you cannot manipulate it. Actually, I'm not 100% sure of this, but I was reading about you shouldn't manipulate it after you have created it. But the first time you create it, and you can create multiple times. I think what you could do is you could do a string interpolation here. If you do it in this format, where you just use backticks here and you put inside whatever you wanna do. You cannot use a string interpolation. That's a good point with the literal syntax, defining the regex literally.
Thank you.
Good question. Other questions or thoughts? Oh, Joanne, maybe I think you had something.
No, I don't think.
All right, cool. Okay. Oh, here's some interesting ones. Like this is a range if you want to match all the punctuation. You can do, this will match any hyphen or any comma or any period or any semicolon or any colon here. And here if we have this text, we match this first period here. There's a detail here, which is the hyphen has a special meaning in a range like this. So if you want to use the hyphen and match the hyphen literally, you should put it first. So because this will be an error. Let's say we have, I don't know, let's say we have a hyphen here. So we have a colon here. Yeah. And we want to match, let's try this. Oops. So if we want to do something like this. Oh. Maybe you don't have to put it first. Let's see. T. You have to be careful. Here, for instance, what if I wanted to match a T followed by a hyphen, or not followed by a hyphen, a T or a hyphen? Wait, let me do the global one. Okay, no, never mind. That will still match the hyphen there. This is matching a T or a hyphen.
Maybe try to do a letter, then hyphen, then something else.
That's a good point. So if we try to put two things in between the hyphen, then that can be interpreted as a range. And actually, this is actually quite interesting. It says range value is reversed. Star chart code is greater than end chart code. But if we do maybe like A to T, then that will match any characters in that range. So you just have to be careful whenever you want to match something here. Yeah, it might have a special meaning. That's just the rule. So let's match this, the equal, or any punctuation basically. And we see that then that's matching the hyphen or the semicolon or the colon here. Okay, let's take a look what else we have here. If you want to negate the range, you can do this. I think it's called the correct character. So this will match anything that is not in the range AZ or AZ uppercase. That's why then that matches the first space because T, H, and E are in this range, and we're searching for what is not in that range. This is how you can negate range. And these are some interesting ones. So 0 to 9, this range is the same as saying \D. That matches the digits. This range with all the spaces characters. This is a space here in between these two. The tab, the R, and N, and F is the same as \S. S matches that. This one, A through Z capital and A through Z lowercase and 0 to 9 plus the underscore are the same as the \W. All these are characters considered word characters, which is what the W is for. Any questions or thoughts on this so far here on ranges and sets?
Do you need to escape a question mark when you're dealing with punctuation so it doesn't count as a not?
Wait, say that again? The question mark?
Like going back to the punctuation, since question mark means like not like
optional.
Ignore, like optional. There we are. Do you need to escape it with a backslash before the question mark to also include a question mark?
Not if we're using it in a range, basically. So here, let's say we want to mark the question mark or the exclamation mark. So you see that they're matching there. I don't need to escape them with backslash.
Oh, okay.
And I just tried, and it seems that even if I escape them, it will still work. So I don't need to escape those, but I don't need to escape them because they're inside the range, because they're inside of the square brackets. This will match a question mark or an exclamation mark. If I want it outside, let's say, what about S? Or actually, let's do it here. S, like that. So this, this is matching an S, or maybe not an S, an optional S, followed by a question mark or an exclamation mark. And here we see that that matches here because we have an S and the optional sort of is there. And the next thing is either a question mark or an exclamation mark. And we can see that here. If we wanted to match, like, what if we wanted to match this? Oh, since we're doing it global here, but if we want to match two, let's say we want to match one exclamation mark explicitly followed by another exclamation mark. Or here, we want to match that or this. These are individual matches. Hopefully we can get into that. These are individual matches. But let's say I want to, so here we have 4 matches total. We have 4 matches total. But let's say we want to match an exclamation mark followed by, now we have 2 matches. This is one match. You see this matching the 2 question marks, and this is matching the exclamation, the question mark, and the exclamation mark. So basically, these are now 2 matches instead of the 4. Now we're matching a question mark followed by either a question mark or an exclamation mark, basically. So to your question, Douglas, you need to escape them if you're not using them in a range like here. We're using a range here. We don't need to escape them. Outside, we're not inside of a range. We need to include it. Okay. Other questions or thoughts? Okay, so let's take a look at this. So quantifiers, we already saw one, which is 0 or no matches. The asterisk is 0 or more matches, and the plus is 1 or more matches. If we do curly brackets and n, or a number inside, that is exactly n matches, n, comma, then space and curly brackets. That means n or more matches. If we're looking exactly for a range of matches, we could do n, exactly n to n matches. And this is actually quite interesting. Notice how the question mark, the plus sign, and the star are actually can be constructed with these quantifiers here. The question mark is either 0 or 1. The asterisk is 0 or more matches, and the plus is 1 or more matches. And let's take a look at this. Let's take a look at here with the example that we have. So here, we have this here. Yeah. Let's say we have these question marks here at the end. And let's say we want to match exactly 2 question marks. So we can use the quantifier like this, 2. And that matches exactly 2 question marks. So this quantifier is 2 of whatever comes before it. We can see that even here in the tools, this is kind of cool. It shows escape, the escape character, the question mark character, and this is nested, which means we're searching for 2 of the exclamation mark. So we can do that. What if we do plus? Note how these matches are different. Here we have 2, and we're matching exactly 2 question marks. If we do plus, plus means 1 or more question marks. Now here we're matching the 2 question marks, and here we're matching 3 question marks. And asterisk for this example, it will be exactly the same. Oh, this gives a warning. The expression can return empty matches and may match infinitely in some use cases. No match found. Character display. I'm not sure what this warning is about. 3 characters selected. Quantifier match 0 or more of the preceding token. Oh, I guess. Wait, let's try this in JavaScript. See if we get something weird. And let's say we have, oops. Let's say we have this string. So we have this string. So log pattern.exec str. I know why this one didn't comment out correctly. So I think that might be just the. Okay, so yeah, this one is a bit confusing. But we see here that when I try this in JavaScript, we're matching index 0. And we even see that that's like an empty string. Wait, empty string index 0. I guess this can get confusing because this star means 0 or more characters, and an empty string and 0 or more characters of the question mark. I guess this means 0 or more characters of the question mark. Well, the beginning of the string is not a question mark, so it's 0 question mark and more characters. So that will match. That's why then I got that warning on the Regex because an empty string will match 0 or more question marks. It's a bit hard. It's a bit mind-bending. But let's go back to the Regex. What do we want to do? Like, we want to find this. This is better. This will find basically any question mark followed by any amount of question marks. So if it doesn't matter how many I have here, those will match. So this is matching any question mark followed by any amount of question marks. And going back to what we had before, where we had a set like this to match the question mark and the exclamation mark. Here we can have this, where we first are matching a question mark followed by either a question mark or an exclamation mark, and 1, 0, or more of them. So this will match this. This matches this. This will match this. Doesn't matter how many we have. And so on. This is matching a question mark followed by either a question mark or an exclamation mark. That this should appear 0 or more times. That's then why we also match it here. What if we have? What if we have a letter here? Then we're splitting in the matches because this is not. It's not a question mark followed by a question mark or an exclamation mark. Does this make sense? At least a little bit. Regexes can get confusing a little bit, but it will come with practice. And these are a little bit of some contrived examples. So these are quantifiers basically. So let's look at this example here. We're matching a range A through Z and capital A is Z, and one or more times. Let's see what this gives us. Let's copy this. This is, oh, that's fine there. I meant to copy the pattern. So we see then now that here we are matching words basically. So we're matching the text doesn't have, and those are independent matches. You see, we don't match the 6, we don't match this. We're matching any character between A and Z, capital or lowercase, and 1 or more times. We see that even if we have a single character, that will still match, because again, this is the plus means 1 or more of the preceding token or of the preceding character, and the preceding character is this range. So anything between A and Z. Questions or thoughts?
What is that? So that would return the index of the first like it would return index 1?
That's right. It will return index 0 actually.
Oh, gotcha.
Mm-hmm. Yeah, you see that if I disable the global flag, which we'll see how to do in JavaScript in a few, it only matches the first word. Mm-hmm. And we get the first dot. Okay.
Question,
yeah.
Alejo. So if we do it with the plus or without plus, is it the same result?
With the plus or without the plus? In this case, oh, actually, yeah, that's a good question. Let's take a look. We don't get the same result. Without the plus, we're matching only one character that is in this range.
I mean, if you're doing it global.
Oh, let's put that flag back on. So, oh, here, I guess I was not looking at this. We get 85 matches. What that's saying is there's 85 alphabetic characters or word characters. Actually, not alphanumeric, just alphabetic characters. But if we do the plus, look at the matches number. 20. Because here we're matching like the entire word, not each one individual character. Oh. Other questions? So yeah, I think we just need to do some exercises on this. Let's just cover this and move on. So what if you want to match like boundaries? You can do the caret to match at the start of the string, or the $sign to match at the end of the string, or backslash B to match the boundaries of a word. And let's see an example of this actually in here. So if we match, let's match this. So we see no warnings. We see this is basically this will match only the beginning. So it matches. It will only match when you see that we have the capital, not the capital, the global flag. If there's another the anywhere, it will not match that one, because this is actually is also known as an anchor. So we see it matches the beginning of the string or the beginning of the line if the multi-line flag is enabled. But this is also known as an anchor that will sort of anchor the expression only to the beginning of the line. So this will match there. It doesn't match anywhere else, only at the beginning of the line. And you can even see that it doesn't match the others, even though they're at the beginning of the line, because we're not using the multi-line flag. If we enable that, now it will match all that are at the beginning of a new line. And the M is just an M here after the regular expression in G. Disable that. Same for if we do want to match something at the end. This doesn't match anything because there is nothing called at the end of the string. Let's see here. Actually, this one is kind of tricky. Let's say end. Let's do this. And let's say we have some other ends here. So here, if we put end, we match all the end, but we're matching all of them. If we're only interested in the one that's all the way at the end of the line, we could anchor it with the $sign, which means at the end of the line. The other one is the boundary. No, this is the D. The B boundary is like if you want to make sure that you are matching an A right at the beginning of a word. Yeah, let's do this. Let's say A. Well, actually, let's see. What is another better example for this? A boundary. Yeah. If we do just E, it matches all the E. But if we're interested only in E, where is the first letter of a word, then we could do the word boundary, which is B. And now that will match only the E's right before a word boundary. And a word boundary is position between a word character and a non-word character position. So this is also another anchor there. This matches, this is not that this is matching. It's a bit weird to explain. But we see that we're not matching the space. If we wanted to match the space, we could do this. Match the space followed by the E. what we're interested in is not matching the space, matching an E at the beginning of a word with the word boundary. And we get that. And we only get the E's at the beginning of the word. So here we can find all the words that start with E, and so on. So those are boundaries to match at the beginning or at the end. And in fact, so I use let's see. Let's see if I remember this.
Is a space the only thing that counts as a boundary, or does punctuation count as a boundary?
That's a good question. I don't remember. Let's check it out really quickly. Oops. Wait, hold on. What did I do? Activate. Let's go to REPL. Mouse pointer keyboard. I wanted to show you something, but maybe I won't be able to. Oh, keystrokes. Maybe that doesn't work on the new versions. Anyway, let me just do this. So the question what is a word boundary? Let's take a look. So what if we have a hello? Actually, no. Like, say there is a dot. So we can see that then a dot also counts as a word boundary because we're matching this E. Even that works as a word boundary. Yeah, any here. Yeah, so matches a word boundary position between a word character and a non-word character. So in other words, it will match anything that's not a word character, basically. Yeah. But it's weird because we're not capturing this. We're not matching the space, or we're not matching that. We're only matching the E. We're just anchoring the search in a way to search for an E after a word boundary. And a word boundary is any non-word character.
No, that's good to know. We could use something like that if we're looking at URLs, for example, and need to parse a bunch of URLs that are all going to the specific root, or root's not the right word, but
Domain?
the origin. There we go. That was the right word. But anyway, sorry. Thank you.
Yep.
It can be buggy, Duke, because some URLs have numbers and they can start with numbers. And you don't.
That's very true.
Well, you could do like the character set, A through Z, 0 to 9, plus, and that will match characters and numbers, and they have to come before a word boundary. Yeah, we see, for instance, that if we don't have the word boundary, this matches H and E before the T, and that's because we don't have the ignore casing flag. Okay, so let's look at some use cases here. This is the test. We kind of saw this one. Here, let's say we want to search for, we want to see if there is a dot there that was spelled with a T, lowercase, or a capital T. This will match true on this one. The text And same here. Well, okay, it doesn't match here because there is no capital or lowercase t followed by an H and an E. There is nothing in here that matches that pattern. And we saw now that this is a character set, which will match either a T, lowercase, or a capital T. Definitive article, let's see, this one, yeah, I guess these are examples where we're using search. So search, we can do the string, then search for the pattern, and search returns the index. You can see it returns 0. Search returns the index at which the match was found. Instead of the array that we talked about in the beginning, it returns the index at which the match was found. So the here, the text that matches that the here.
And since it's returning an index, I guess if there is no match, it return a negative something.
That's a good observation. Yes, whenever most functions or methods that return an index, but there's no match, they return -1. Okay, so here, this is an example. This is a good one. Like, we're using replace here. Let's actually see, run this one. It's a bit long. What I wanted to show you earlier is that I use Vim, or I use the Vim key bindings or key shortcuts. And if I want to go to the end of the line or the beginning of the line, is the same characters as in the regex. If I want to go to the end of the line, I can do the $, and that takes me, if I type $, with the Vim key bindings, that takes me to the end of the line. If I do the correct, it takes me to the beginning of the line. If I do W, that takes me in between word characters. So the point that I wanted to make there is that there's some stuff that either Vim borrowed from regexes or that regexes borrowed from Vim. More likely, I think regex was before Vim. So here, let's take a look at this. This is going to match. We know that this is going to match with a capital T or a lowercase t. And let's see then what we get. We see that instead of the text, we now have a text. We replace whatever they match on the pattern happen with a. Let's see what happens if we have the number 1. I'm not sure what will happen here. If it will match, if it will replace all of them. Let's try it. Let's try it. We have the text here, the number. Let's run. Okay. What do we see here?
Replaced only the first one.
Replace only the first one. So let's take a look at our first flag here from JavaScript. Where if we put G global. So again, it match only the first one. It replaces only the first one because only the first one match. We talked about how the regex will match the first one and stop searching. If we do G, it will keep going. I hope. See, a text does have a few numbers. A number 1 exactly. So that replaces the text here and the number. Putting instead of the, putting a, replacing. So that's the G flag there. Actually, let's also do this one in. Let's actually also do this one here. Console log. Now that we are seeing the G flag. So without the G flag, if we, or the global flag, if we do a definite article that match, that exec str, we see the array that was returned, which is an array with the match and some properties about the match, right? And we see here that we only match the first one. We only match the first one. Now let's put the G flag, and this is a difference. This is the main difference between exec and match. Let's see the G flag with exec right now. So the G flag with exec doesn't do anything. It just doesn't change anything here. So it will still, the regex will match all of them, but we'll need to call exec multiple times if we want to access the other ones. Well, let's try with match. Match and then reverse this, which is a definite article here and str here. With match, and we have the G flag here, we're gonna get all the matches, and we don't get the indices. We get the matches, we do not get the indices. We get an array with no properties. So that's the main difference between match and exec. When you don't have a G flag for global matching, they are exactly the same. When you have the G flag, they behave differently. The exec, let's put it back. A definite article, str, exec, executing that Regex. Exec will match only the first one. Only the first one. The key, though, here, this is one confusing part, is that you could use exec to access the other matches as well, but you'll need to use a loop for that. Let's actually see that here. Because let's say, what if we want this is a limitation of match. Match can give you all the matches, but what if you're interested in all the matches plus the location of those matches? We'll need to do that with exec. And let's take a look at this loop here. While, let's say match is this. Say console log match. So hold on, let's go back here. So str.match gives us the matches of this pattern, and we search on all of them. So we get, we search with a global flag, so we search the entire string. We match the text and the number, in the number. And we found that if we want to do it with an exec, we'll need a loop. We'll need a loop, and let's take a look at this. And we run it. Now we get two arrays. This is the first one, and this is the second one. And these are the matches then. So the first match, from the text at index 0. The second match, from the number on index 33. If we needed to like accumulate it, and we can have like a variable here, accumulator. Let's say we wanted to accumulate the match. Yeah, maybe when we have an array, an object, then we can do accumulator match at index 0, and the value, let's put the index. This gives it correct. Yeah, like this is if we wanted to sort of extract it in a in a more elaborate way, basically. But just know that if you're using exec and you're interested in all the matches that were found, you're gonna need to use this here, this while loop. This while loop is saying execute this as long as this, execute the while loop as long as this expression is truthy. So on the first, this expression, this is kind of weird because this is not a Boolean, this is not a true or a false, but the truthiness is what's applying here. Here we have an assignment operation, right? We're doing an assignment, and an assignment will resolve to whatever the assignment resolved to. What that means is here match on the first iteration match, and we do exec. This entire thing will match will have an array. It will have an array of the first match, and is an array a truthy or a falsy?
Truthy.
Truthy, right? So an array is a truthy. So then this results into a true, and we console log the match. Then we get that first match. Then since the G is making the regex search through the entire string, it moves from there and it tries to find another the in the string. It matches on this one, and that then makes this expression evaluate again. So it executes the. Oh, actually, we can see it maybe without the while loop, but that makes this execution go on again, and now is matching on the second the from this string, and on the last one, after it has searched, after finished searching everything, this match will be null because it cannot find any more the in this string. Then when it's null, then the null is a falsy. The while loop finishes there. I was thinking, what if we do this? Since we know that this has two matches, maybe we can do this. Match one. Two. Let's see if these two console log match one. The accumulator is undefined, but actually we can see it here. See if the while loop is a bit confusing. So we see here that this is part of the regular expression. When we execute the irregular expression first, we find the first match, and the first match is the first the here, the text. If we execute the regular expression again, we are going to match the next the here from the number. The regular expression doesn't start back from the beginning. And that goes back to, do you remember we saw it match one dot last index, two dot last index. Let's see. Oh, this is kind of hard to see. Oh, undefined. Oh, actually, not the match. I mean the pattern, definitive article. Oh, actually, this is quite interesting. We see that the last index of both are the same. Okay, so there is something under the hood that I'm not sure about. But my point here is that if you want to use exec to find more than one match, and you want to find all the matches, you will need to do it in this format with the while loop. And I'm using the accumulator just to make it look nicer. But it might differ from your use case. so this is to exec. Remember that exec will give you the match on the index. When we did it here with match, we got the matches, but we did not get the indices. And then this is the main difference on exec and match. Without the G flag, they behave exactly the same. With the G flag, match will give you an array with all the matches. Exec will give you only the first match, and if you want to find more matches, you're going to need to loop in this fashion. Yeah. Any questions or thoughts?
Question, Alejo. If we remove the G flag and you call the function twice, will it have the same thing? It will return undefined? I mean null?
You mean like if this while loop will still keep searching? Let's say. Oh. We got an infinite loop. Which is interesting. Potential infinite loop. You can disable this from settings.
So when you remove the G flag, when you call the function again, it just executes again as a new one. And when you have the G flag, it's like it keeps track of the last time it called itself, right?
It sort of keeps track of the last match it saw, and it moves on to searching from there forward. I actually read something about this on the MDN article, but I just don't remember exactly. But I remember seeing something that said an infinite loop, basically. Yeah. But yeah, so if we don't have the G flag, what that will do in this exec, and we have it here in the while loop, is that it will restart the search from the beginning of the string, giving us then this infinite loop and never reaching a false value or null. Okay, so that's been quite a lot of stuff. Let's just move on through here so that you can do some exercises. Here is, we're using split here, and we can pass in a pattern to split. Here we're passing the word boundary to split on the word boundary. And what that ends up giving us, let's actually see it in running. Split, let's comment this out. Oops. Sorry. Let me put back this G here. So this is sort of interesting that we're splitting on the word boundary. So we're splitting on any character that is not a word character. And it's kind of weird. So if we split a string on the word boundary, which is /b, we get the space, we get text, we get every word and everything in between words, because we're splitting in that sort of weird space in between a word and how do I explain this? We're matching this this place here that is between a word and something that's not a word character, which is the space. And then we're matching this space here between this space and this word. And basically we're sort of chopping the string like this. If we imagine those are word boundaries, those vertical pipes. We're chopping this here. The space is its own thing that comes there, and so on. So this is the word boundary, and here we're splitting on that. Okay, so we saw some of this global multi-line match all. The global here this pattern is matching the with a capital D, T, or lowercase t, followed by a word, prepended by a word boundary, followed by a word boundary. So this will match only the if there is only, if that is by itself. So we can see here, this example, we have make the thing do the thing, there is no try, just the done. And we can see that we're using replace to match that pattern and replace that pattern with an A. And there is no, yeah, there's this the, but this the is not, is followed here by a word boundary at first here. This could be a word boundary, but there is an R at the end. So it doesn't match that one. That's why that one doesn't change. It only matches the here and the here, because that is surrounded by word boundaries, and that's what we're saying here with this pattern, word boundaries. And that happens globally. That's why all of them get replaced. If we forget the H, we'll find only that only this one gets replaced. The first the thing. What is this one? Notice how G after, yeah, stands for global. Find all instances that match. Oh yeah, this is again, this is sort of like another example here. Oh, I forgot about this the here. The thing, the dawn. So there's actually 3 matches. Yeah, exactly. And with match, we saw this with match. Match returns the matches, no indices, index, no index, etc. Yeah. So for instance, this is a handy trick for counting occurrences of a word. You want to see how many times the appear in the string, and by itself, not like in here. Then we have this pattern, and we can just count the length, how many of those that we see. So other useful flags. This is the pattern, and the I flag is for ignore case. That matched lowercase and uppercase both. The multi-line, what it does is it treats the caret and the $sign to be at the beginning of the line, at the end of the line, not at the beginning of the whole string and at the end of the whole string. If the string has multiple lines on it. U for Unicode, this one, I'm not even gonna go into it. This is if you wanna match like emojis, or if you wanna match characters in the Unicode code points, you will need that flag. And let's see here a more practical example. So actually, let's take a look at the I pattern briefly here. So we saw this pattern, A through Z. We have a global A through Z. Wait, is this? There is no match. Should this give us a match? The word, oh, this is a digit. This is looking for a digit. Here, let's say we're looking for this example that we had before. So this will match a lowercase t or a capital T, and followed by an H and an E. And we see these matches happening here, and we have the global flag, that's that G. So the ignore match, the ignore casing will allow us to do something like this. Remove this and have the, and put case insensitive, and that matches them. Yeah, because the case is insensitive now, and so on. So that's what that I is for, that I flag. And we could do that in JavaScript just at the end here. So let's take a look at this example here. This is a bit more practical. Let's say for some reason you're creating a form and the user needs to type in their IP address, or this is actually the forms that are used to configure your routers. I don't know if you ever looked at the configuration of your router, but you can set up specific IPs. They have some input validation to make sure that what you type in that input box is an IP address. And let's take a look at this here. Here, let's copy this pattern. So this will match any digit. We saw that this is what the \d stands for. And what is this called? What do we see it?
I don't remember, but it's kind of limits, like bound, 1, 2, 3. Like
Right.
it has to be like 1 digit, 2 digits, or 3 digits.
Right. So that's a quantifier, as I hover over here. Quantifier, match between 1 and 3 of the preceding token. So this means match a digit one digit up to 3 digits, followed by a dot. And actually, I think I remember, did anybody get asked something about like an interview question with IP addresses? I think at some point I remember seeing one of you tell me that there was a question, like an interview question, had to do with IP address. I don't remember exactly, but oh yeah, I think the question was like, find if this is a valid IP address, and the IP address had to be in the range 1.1.1.1 to 255 to 55 to 55. And with a regular expression, that would be easier. But basically here, then we're saying match a digit, match 1 or 3 digits, or 1 to 3 digits, more I should say, followed by a period. Note how we need to escape that to match the literal period, followed by 1 to 3 digits, followed by a period, followed by a 1 to 3 digits, followed by a period. I actually think we could actually repeat this in an interesting way. We can see that maybe next. And this is just the same, a digit 1 or 3 times. So if we do an IP address like 1.1.1.1, that's a match there. Or we do 101, 65, 112. That's also a match, because then here we have 3 digits followed by a little period. If I remove that, then the entire expression fail, or doesn't, not that it fail, it just doesn't match. And we can match up until 1. If we have like no numbers followed by a dot, that doesn't match anymore, because the pattern is saying that at least one of them must exist. Questions or thoughts on this regular expression?
How do we specify that an input must have every single character, but not necessarily in the same order? Like, if we had to find an anagram, I feel like we could probably use a regex to do it. But would it just be simply making a character set with the word that we're Like if we put car into into that, would it find CRA?
I'm not sure I fully understand, but you're saying if we have car is the same as, no, what's an anagram? Race car? Wait, no, I think I'm getting confused with palindrome.
Oh no, yeah. No, I was saying like an anagram. So you could like car would also like a like RAC is an anagram, and CRA
These are
exactly.
all anagrams, right?
Yeah.
And you want to find, you have two strings and you want to find if they're an anagram of each other, right? With regex, I get the same sense that there must be a way. Oops.
I didn't mean to sideline everything. I apologize for them.
That's fine. I'll need to look at it more deeply into it. Let's keep going here. This is an example. This is another example here. This goes back to Joanne's question about groups. So if we want to match tra la 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 in a song, we can just wrap it in parentheses and say that must appear 3 or more times, and with the quantifier. And I was thinking that maybe even this one we could do. This one we could do. I was thinking, what if we wrap this in parentheses? Wrap this in parentheses, and we see that it must appear as 3 or more times. Wait, actually 3? Yeah, 3 or more times. That will match those 3, but it doesn't match the last number. So there's not that big of a difference here. Yeah, but we can group it. Okay, let's see. I think that will be the last part. We're not going to go into nested. Let's look at this one really quickly. This is an OR. The type is the OR character. So actually, if we go back to this pattern, I believe we can also express this pattern if we say this. A T or a lowercase t or a capital T. So this is the OR alternation, acts like a Boolean OR, matches the expression before or after that. So this OR is helpful when we have something like this. Let's say we want to find all the numbers spelled out. We cannot do it as a character set because a character set is each single character. We'll need to do it like this, in this fashion. And let's just take a look at the. Let's take a look at this one, the groups. Where did my repo go? And let's take a look at this first. We see match. Forgot to do let str. Match. Oh, let's see this. Duplicate declaration. Of course, as I'm not commenting out everything. Okay. So here we are matching the 3 LA followed by a space. You can even see that when I hover over it, the VS Code, no, this is not VS Code, but REPL also sort of, it matches that as I'm hovering over it, and it's matching those. And here we're matching 3 or more. What I wanted to see was the find. Wait, match. Groups. I was expecting this to have something, to have the groups that were found. Oh, I guess maybe there was not a group here because it's matching 3 of them. That's just one. Let's see. This is an example, but this, and again, here we're doing the while loop to find more than 1. Let's see, I think there must be a simpler example we can try. What if we match, what's going on? Trala. Yeah, so this can be a bit hard to see, but we see that we find a match where we found it, which is tra followed by an LA followed by a space. And anything that we put in parentheses gets put here as a second sort of as a group. I was expecting it to be here, but then I don't remember. I will need to look into why this one will show here. But it makes that into a group. So if, for instance, we do this, that'll create 2 groups, the first one and the second one. And this matches, trala will match on the first trala, but we have 2 separate ways to access these ones in the match, as we see. So a match here, and the 2 capture groups is tra and this is if you want to like split the data and access it more complexly. This is an array now with 3 elements. When we don't have any groups, we get an array with 1 element only. Right? 1 element, which is exactly the match. When we want to group to have stuff separately, then we can use parentheses, and those will be stored in the output array as in separate indices. This is an example where if you want, let's say you want to extract the full month and the year, but you also want to have the year separately. What you could do is you capture it with the parentheses. That's what the parentheses really do. You're sort of capturing there with this is just a word character 1 or more times, followed by a space, followed by a digit 1 or more times. And then you're capturing this entire thing with the outer parentheses. That's what you get this. The first one is where the entire pattern match. The second one is the first group, which is the first outer parenthesis. And the next one after that is the inner parenthesis, where the next capture was done, which was around only the digits. And then we get just that. And that's similar for the rest. Let me just talk about this, and that will be it. Controlling greediness. So the our quantifiers, when we have like plus, we talked about quantifiers. Plus is one or more matches. That will match. Actually, let's just take a look at these ones. These are very good examples. Actually, let's do it here. So let's say we have this pattern. Any character followed by, so we're matching the opening angle bracket followed by any character, and any character one or more times, followed by the closing angle bracket. Well, you can see that we got 4 matches, and these 2 we can ignore. Yeah, we got 2 matches because this is matching this opening angle bracket, any character one or more times. So this is any character, and this is one time. This is any character. This is the second time, and so on. So all of this is matching until we see this dot and a plus is matching everything that I have highlighted, and then the opening angle bracket matches literally the angle bracket, and the closing angle bracket matches literally the closing angle bracket. So here the plus, the period, and the plus is matching the entire, all these that I have highlighted, which may not be what you want. So this is why we said the plus quantifier is by default greedy. So it will try to match as many as possible. If we want to make it not greedy, we can use the question mark. And now we're able to select only the tag. So this is saying, okay, match any character one or more times, but as few as possible. We can see even it says lazy. Makes the preceding quantifier lazy, causing it to match as few characters as possible. Basically, so that we don't cover the entire thing. So that is how we can control greediness in the quantifiers. This is with the plus, the asterisk. What was the other one? Quantifiers. The question mark, 0, 1. Oh, I guess like that one doesn't. The question mark, 0 or 1 time. There is not, that one is not greedy by default. These 2 are greedy. This can match 0 or more times, 1 or more times. The question mark is not greedy because it can match 1, 0 or 1 only, not more than that. So only for these 2. Okay. So let's do a few exercises with this. So I want you to go here. I'm going to share this link with you. Let's see. So there is some additional exercises here, but I think I want us to work through this Regex one because I find I was very interactive. But maybe before we do that, let's do a few of these together. So let's do this then. Find I'm going to share this link here in the chat. Where is Zoom? Chat. So I just sent that there in the chat at the bottom under additional exercises. And some of these we did here. Okay, so actually let's do this here. What I want us to do, yeah, actually let's do this here. I'm going to create a new repo and regex exercises. And then what I'm going to do is I'm going to copy all of this into here. Oh, I didn't copy the numbers. And then what I want us to do is to tackle one. Which one? So I'm going to share this. Copy. Zoom chat. So go on this repo. Pick one. Oh, but something I just realized is going to be a problem. Is that all of them have the same variable name. So let me just remove the let. So we can reuse it. HTML, okay. Okay, so what I want us to do is write the regex and the execution of the regex here below to match what this is asking you for. And you can do any of these. Don't just each one of you pick one at random and tackle that one. And then let's talk about it. Does that sound good? These are, just copy these exercises from the README. So just below it, write the regular expression and execute it with match or with exec to answer the question prompt that we have here. And then let's talk about it. Let's see if there's any questions arise. just pick one of these. Everyone, pick one and start attempting it, and then let's do that for 5 minutes and let's see how it goes and talk about it. I'm gonna stop sharing for a second. Let me know if any questions arise. Oh yeah, I'm looking. I think there's some variable repeated like pattern. Just pick a different name, or maybe pick pattern and your initials pattern, um, or some just a different variable name. Okay, I only see some of you. I'm not seeing everyone. I don't see. Let's see. I don't think I see Kathy, Jonathan, Owen, or Joanne.
I'm doing it in a separate repo.
Okay, got it.
Same here.
Okay, cool. That's fine. Thank you for letting me know.
Same here.
Cool. Oh, Douglas, I think you're doing it in the opposite order, where if you do text, if you have the string first, then you need to do that match, or so text that match or pattern that exec. And then that would be the string. Yeah, exactly. Okay, I see some good answers here. Okay, let's take a look. Let me share my screen again. Desktop 2. Let me hide this. Okay, so this first one we had sort of seen. We'll find the in the text below, and here, yeah, just find it. Let me see if we run this. Text.exec is not a function. Line 20. 20. Exec. Wait. I think, yeah, this was fixed. Oh, yeah, actually. This one. This is, oops. So this one, again, just match the T capital or the T lowercase followed by an H by an E. Oh, I guess we have some other problems. Oh, maybe it's because some people haven't finished here. Oh, I think Joy, you're still there. I see you. Oh, let's see. Search as is not defined. Oh, right here it was this finder as. Oh, okay. This is gonna be hard to process. Let's put it here. 1. So the 1 is here. We find that the is at index 15. And we look at this string. The mass, that's the first piece. That one shouldn't be too complicated. Find all definite articles of the in the text below. Now we have to find all of them. There should be, how many are there? 1, 2, oh, well, as I highlighted, it's easier to count. 1, 2, 3, 4, 5. 5, let's take a look at Doug's solution here. 2. 2, we see 1, oh, oops. 1, 2, 3, 4, 5. Got it. So let's say like that length here to find all of them. Well, actually, it doesn't ask that for the exercise. So this is a good point that here you have to swap it between exec and match with the J flag, right? Cool. Okay. Find the first character, capital letter in the text below. This one is match A to Z in the character range and execute on the text. So this one, 3. There we go. G at index 11. Awesome. The first digit. This is just the digit exec. That should give us 3. We already see it here. The first capital letter or capital word. Oh, okay. So this one is actually asking for the first word, but we're matching only the first letter of the first capital word. Let's take a look at this one. 4th. So any ideas, anyone, why this is not matching the word great, only matching G here?
Does it have anything to do with the A to Z is only looking at the letters?
Yes, yes. This is only looking at what letters. What letters? Only what letters?
The letters between A to Z.
Right, and specifically the capital ones. So this will match if we had this. Where is it? That matches there if it's all capital. But we're actually interested in the first capitalized word, which is great. Here. So how can we match a word that first letter is a capital and the other red letters are not? Any ideas?
Maybe by putting dot after.
Like dot here? Okay, let's take a look. Run. 4. Oh, we got the great, the bait. Well, we actually only interested in the great part. Other ideas? Anybody else?
We do the backslash b.
We could do backslash b, like here, I think. Oh, actually, no, we'll need to do, yeah, actually, we can't use the backslash b here either.
No, at the beginning, no?
You mean here? It's still a great debate. Did anybody else manage to get this one?
How about backslash b without the dot at the end? And
That's b here, no dot, no plus. Matches the G.
What about just putting 4 dots and remove
4 dots. Let's try that.
take out the plus.
Four dots. This is 4 dots, right? Let's see. Run. Oh, great. We got great. Joanne got it. Awesome.
is there a way to do it without knowing the length of the word?
That's a good point, right? So for this one, we will need to know the length of the word. What if we don't know the length of the word, right? I think I heard something, but didn't know who was that.
So we do the negate space, like you don't want a space.
Joy, I'm having trouble hearing you. I'm not sure if it's the volume on your mic. You said negating. That was the last thing I heard. Like negating here.
Can you hear me now?
I can hear you now.
Negating it, like I think it would have to be in a different range. I'm not sure. It might be at the end. You do up space.
Oh, like up space like that.
Maybe.
Let's try. 4. Oh, much no. But okay, so here we know that this is gonna match any capital letter, and that's the first part of the word. And now we want to make sure that so this matches this, but we also want to match the rest until there is a space or until a word boundary. So what if we do the word character? The word character one or more times. Let's try this. We had great. Yeah. So, and it doesn't matter. It actually doesn't matter if this is a capital here. If that matter, then we could still do it. But basically here I'm matching the first character has to be a capital. That's this taking care of this here. Everything after that, just be a word character one or more times. Another way in which you could do this is if we have this A through Z. These two will work exactly the same, I believe. 4. Oh, that's because then I have this. If we don't have the capital in the middle. Yeah, great here. Again, we're matching the first one to be capital letter. The second one is any letters from the alphabet, one or more times. Does this make sense? Joanne, what do you think? Give me a thumbs up if it makes sense. Joanne?
Yeah. I was just looking at the first solution you gave.
Okay, the W one.
Yeah.
Yep, these two will, for this case, they work exactly the same. So if we have this one, match is great. Even if it has a number in between, let's say great, and we put like this is a 4. That would not, okay, that matches, yeah, because we have the word character. So any word character plus one or more times. So 4 is if it's in between characters, it's a word character. I wonder if it's even if it's by itself. I think even if it's by itself, it will match it. But that wouldn't match if we do this, because now we're looking only characters within this range. And 4 is not there. This will match only GRE. Because then at the 4, that doesn't match a range A through Z. So those are like small difference there. Okay, let's keep going. Let's see this one. This is actually an interesting one. You have the CSS colors, and some of them are hexadecimal, some of them are RGB. And you have to find all the ones that are hexadecimal. Let's take a look at this one here. CSS matches. Okay, we had 1, 2, 3, 4, 5, 6, 7, 8. Awesome. I think we had 8. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. I think who wrote this? I think it was Joey. Joey, do you want to talk us through this one?
Okay. Well, I added the last one because sometimes there's a shortened hexadecimal version.
Yeah, that's a good catch.
So I search for the number symbol first, and then after that, look for a range of digits or letters that are A through F. And I catch capital letters too using the I switch at the end. But also I added a condition that the match has to be between 3 to 6 and, or 4 to 7 in length. Or the range is 3 to 6 in length. And added the global switch.
This is cool. So you're matching like in 3 to 6. Actually, let's try this one on the Regex tool. Oh, it has some space, but that doesn't matter. Because I think this is a cool one. Regex or no. So choice match here. Using global and ignoring the H. Okay. So, okay, yeah, we get the matches. What I was trying to find is this will match any number from 0 to 9 or any letter from A to F. And that should repeat at least 3 times or 6. Oh, okay. I see. Yeah, 3 like in this case, or 6 like in this case. Yeah, this is great.
I probably should separate it the length to only be only 3 or only 6, because if I don't think there are shortened versions that are 4 or 5 in length.
Oh, right. That's right. I think for CSS colors in particular.
Maybe not.
Yeah, actually, I don't know. I don't know if it will be 4 in length. Yeah. that's a good. This is a good one. Questions or thoughts on this one? So what would be the pattern if I want to find if I want to get only the stuff inside of the RGB parentheses?
We look for RGB, open parentheses, 3 dots, maybe comma, 3 dots, comma, 3 dots.
And also, so actually, this is another special character in a regex. A parenthesis is a special character in regex, so that's why this one is not matching. So we need to escape it. Okay, and you said 3 dots.
I don't remember. Is it guaranteed to be like 3-digit number? I don't remember. No.
No.
It can be only 1, for instance, right?
Mm-hmm.
Yeah, so this is not right.
Any other ideas? What is the what matches the digit the digit character?
It's /D.
/D. Okay, so let's do can be 1, 2, 3, followed by a comma, a digit 1, 2, 3, followed by a comma and digit 1, 2, 3. Matching the rest. Cool. And if we want only, I wonder if we have this extra parentheses here. Yeah, we see this is those are extra parentheses is a capturing group. You can see it here. Let's see the other. Oh, this is kind of cool. Replace details. Yeah, this is kind of cool. You see that where the match is, and since I've surrounded that with parentheses, this I'm only interested in this guys here. Questions or thoughts? Okay, let's take a look at the just a few last ones before we break off. Let's see these ones. The HTML tags. This one work? Yep. I think you did this one. Do you want to walk us through?
Yeah, of course. So I triggered the closing tags because like each tag is open and close. So just to have a list of uniques one. And so that's why I triggered the closing one, doing like the.
Oh wait, so you're targeting the closing tags like this?
Yeah,
ones.
just the closing one. Yeah.
Okay, I see. Mm-hmm. So
Yes.
explain to us this pattern here.
Yeah, so I'm looking for like the less than sign, like the open tag, ignoring the slash.
Or you mean escaping the slash to be interpreted?
Escaping. Yeah, escaping. Yeah. And then I have dot like everything plus like any character plus like taking everything and taking the lazy part of it just for one tag, doing it global, and it gives me an array of all the closing tags. And then I loop over them and just remove the tag signs, like the greater than and less than.
I see. Let's take a look at this array that you have here. Oops. Console log close tags. Okay, so you get this. And then you're just chopping away the angle brackets, right? The angle bracket and the slash and the closing bracket. And you do that with this substring,
Yes.
right?
Yeah.
Okay, yeah, this is cool. this is cool. One detail here is, what if we have this tag here? I don't know. A tags do not exist. Oops, text dot is not defined. Wait, did I change something, or one of you changed something? Line 40. Line 40. What is here? Pattern 2.
I'm sorry, I think that's me.
Oh, okay, no worries. Oh, if you have the pattern, if there's a problem with the pattern number, the name, doc pattern, CSS pattern. Okay, I see. Ouch. Okay, cool. Yeah, so it depends here if we want to do here this a tag match. And Amin is trying to fix it. Let's see.
Uppercase tag are valid or no?
Uppercase tags are valid, yeah. Okay. But now I'm getting no. But I think that's because you put this these curly brackets. Oops, no. Console log, the two new lines, then close tags is no. Oh, right, it's because we need to match this one or more times. One or more times. Cool. Then there we got there. Yeah, as you said, if we put the I, we ignore the capital, and so on. So you can think of it like whenever you're using VS Code and your VS Code is telling you whether something exists there, whether an HTML is an invalid HTML or it draws the squiggly line underneath, something like this must be going on, checking if it's a valid HTML tag, and so on. And even like whenever you're doing parentheses or like console log, you calling console log. Console log has a pattern, which is you do console.log and you have to have an opening parenthesis and a closing parenthesis. It doesn't matter what's in between, but those must be so that it runs correctly. So VS Code will check for that. It might be actually that specific one might be like a problem that some of you might have seen called matching parentheses, and it's a bit different. But yeah, okay. So this is it. I wanted to introduce you to regular expressions. See that they're not as complicated, or they are complicated, but that we can start grasping them. And I hope you get a glimpse to, what are some of the stuff you can do with them. Again, it's for like processing text, and a lot of if you want to do input validation, making sure that something is an HTML tag, making sure that a date is in the right format, a font number is in the right format, and all of that. Cool. Any final questions or thoughts? Oh, a bunch of people left. Oh, I guess that makes sense. I'm 15 minutes over. Okay, let me know if anything comes up. Keep exploring the Regex. Do that in any additional time you have. Complete the exercises on Regex 1. they're super helpful. They will be, yeah, they'll just make you better acquainted with regexes. And the cool thing about regex 1 is that, wait, am I still sharing my screen or no? I am. Yeah, it's like, it gives you, you know, maybe you didn't get most of what I talked about because the way that I explain things. Regex 1 gives you, you know, a nice introduction and a nice exercise here to try it out, and in a different wording and so on. And there's like this, like, I don't know, maybe 20 exercises here, one to match digits, any character. Yeah, so super helpful to complement what I try to showcase here. So, you know, highly encourage exercise here to be fully regexes. I use regexes very often. In fact, when I was writing this README, actually, let me go back there. I use a regex to, I had this, what was it? This. I used a regex to wrap this table I took for somewhere else, but it didn't have the, let me show you here really quickly. Go to file. I mean, it was a small thing, but it was still fun. I guess that's gonna be more complicated than I thought. But I use regexes very often when I'm finding and replacing on VS Code. Actually, there was an example where I was working with Suzette, and she had to, and actually I had to do this as well. I changed my backend, so now all my routes start with /API. So I needed to change all my front end to make sure that all the routes, all the URLs in the front end has /API in the front. What it is, I target access.whatever in parentheses, and in a parenthesis a string, and we replace that with access.whatever plus /API plus whatever I had there before, and so on. So yeah, they're helpful. I hope you get a glimpse about how you can start using them, or at least whenever you see a problem or you want to extract information from a bunch of data, you think of a regex, how a regex will help you there. Okay, that is all for today. I will be checking in with some of you one-on-one. Just make sure to check your email, be in the lookout for an email for a one-on-one with me. I'm checking in with everyone, so I'm not gonna get to everyone today, but throughout the week, you and I should be meeting one-on-one at some point for at least 15 minutes. So be in the lookout for an email and a calendar invite for that. Okay, so I hope everyone has a good lunch break and a productive afternoon. I'll see you all at checkout.
Thank you. See you guys later.
Again, thank you very much for this. This was a great lead in. I was going to try to do a lot of this on my own, and I appreciate having this. This is cool.
Yeah, you're welcome.